you see lesson 2 of project plannings and regulation, and the title is labor, material, and equipment utilization, which is chapter 4 in the textbooks. So for the objective for today, we list the factors affecting the job site productivity. Also know how to calculate the labor productivity index and productive labor yield. Also classify the 3 types of measure for materials and calculate the cyclic capacity, daily production rate, job site productivity, actual cycle time of construction machines and or equipment. So this lesson basically prepare for us to move on to the first portion of the class, which is focus more on the cost estimating, bidding, and pricing constructed facility with is can be residential, it can be heavy infrastructure, industrial, commercial, institutional, something that we discussed in the very first lesson of this class. So let's talk about the productivity, and as you can see, everything to improve effectiveness of the whole economy or any sector of the economy or for a project or for our own, we're talking about the productivity. So it's very important, and I believe that what we learned today, it can be applied in our daily life as well. Productivity. And for productivity, we deal with the 4M. It used to say 4M. 4Ms. What are the 4M we are talking about in here? And just to have it make it easy to remember, but some might not be a proper word for today language. The first one, and you will see what I'm talking about. Manpower, and that have a gender discrimination in this word. So you can say that because I just say the M, so easy to remember, but it should be, we should say loudly now, it's human power, right? Human power. But just for the purpose of the easy to remember, I still keep the M in that human power in there. And the second M that we are talking when we work on productivity, that it will be materials. And then the next one, we talk about the machine. And the last M in the 4M is will be money. So you are the 4M that we deal with in productivities. And for today, we will emphasize the first 3: human and power, materials, and machine. For the money, costing, bidding, pricing, we will talk in the coming classes. So keep that in mind. So with that, what is productivity? There are multiple definition in here, but let me give general equation for productivities for the whole economy or for any sector or any work. It's basically the output divided by input. If you put input less than the output, that you are good. You have high productive. And then output or input can be measured by the money, like how much money we put in and how much revenue, value added work that you can get out of that activity, that we can have output. And now if it's more on the side of the human powers, we call it labor productivities. So that more about our class rather than the microeconomics, which is the output of the whole country, etc. So in that case, it will be for labor productivity, it will be output over labor hour. How many labor hour you put in, what output you can generate. So output, it can be money as well, but it can be the physical unit. For example, if we lay out the tile for the floor, output how many square feet you can do per hour. That basically labor productivity. But keep in mind, some company, they use opposite in reverse. So the flip numerator become denominator and vice versa. So sometimes they can use the other equation. So keep in mind what they are using so that you can interpret the labor productivity correctly. Some, let's say, labor hours over output. Keep that in mind. So it basically opposite. If we measure with output on labor hours, so it means that if that number is increasing, it's good. But if we use labor hour per output, you put that number increasing, it means that I spend more labor hours per unit of output, then it's not good. So keep that in mind. And let me give you an example here. In these scenarios, for a real project that we took at Edwardsport IGCC, that integrates gasification cycle project power plant in Indiana. And as you can see here, with different package, with different contractor, different area, and different commodity, structural steel, piping, instrumentation, cable trays, and you have the budget quantity. So basically the planned quantity that they about to install, and UOM is unit of measure, TN stands for ton, LF linear feet, EA inch, etc. And then you have a budgeted man hours, so basically the planned man hours that you have, and labor hours I can say in here, and then the productivities. So you have that one, and then current quantity that they apply, quantity completed, hours spent, and actual productivities. So let's see the first one. The first one, structural steel, you have the productivity, the plan is 12.15, and the actual productivity is 12.59. And you may wonder whether between the actual or plan productivity, which one is better with this number. So to do that, we need to know what equation they are going to use. So basically, productivity measured by two ways in industry, either output over the labor hours or labor hour over output. If you think the number here with this, you can see for this company, this is Bechtel, and they use the productivity here. It equal to, as you can see, the labor hour divided by the budget quantity. So you have 5,611 divided by 7,045, you get 12.15. And then they do the same for the actual productivity, and 12.59 with the actual hour spent divided by the quantity completed. And as you can see here, the number from budget productivity and actual productivity, the actual productivity in higher, but in this case, it means that this project in this item productivity is lower than expected, lower than what you expected, because they measure labor hour over the output. So keep that in mind. And why labor's hour is very important. With this same project, I show you the next one here. For this project at engineering by discipline for the power plant here, and this is a 3.5 billion power plant project. And as you can see, engineering hour, project controls, estimating, procurement contract. So any project that require hundreds of thousands of hours, as you can see here for this project, engineering design work, 617,000. If you time engineering hours about 100 per hour, you see how much it is. project control, etc. And it can also break down by the discipline. You have engineering management, project system, civil architectural, environmental. So all multidisciplinary work required to do a big project like this. And that's why we learn yes, to understand the nature of the productivity, the nature of the labor hours, regardless of that either in the engineering design state or in the constructions that you have here. And you have multiple major in our class, only civil and environmental, but as you can see here, they have multiple major that you have for engineering for a project like this. So, and because it's very significant, so this one, as you can see, before they start, they have to determine the budget hours for the work based on the reference of the project that they did in the past. Because you see, labor productivity is very important. We need to budget it accordingly. So with that, let's go back to the note here with that equation, and that concludes the concept of productivity. In the next video, we will talking about the what are the factors affecting the job site productivity and the effect of job size on productivity.